Hello and welcome to my science tutorials. In today's video, we are going to be talking about the introduction to differentiation, precisely the product rule. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So the product rule. So let's look at this scenario. Assuming we have a function of the form y is equal to what? U and v, where both u and v are what? Are functions of x. Are functions of what? Of the variable x. Okay, when this is the case, we need to use a rule that we call the product rule. So by u and v being the functions of x, I mean, let's say u is equal to what? A function, let's say s squared plus 4, and then v is a function, let's say s cubed minus what? Let's say 5. Okay, so it means our function y becomes what? A function of the form what? S squared plus 4, and then what? S cubed minus 5. Okay, if we look at this function over here, we can see that we have a function multiplying another function. So we have two functions multiplying each other. So whenever we have two functions multiplying each other and we are to differentiate this function, we use what we call the product rule. And according to the product rule, our dy dx, or our differentiation, becomes what? V du dx plus u dv dx. What do I mean by this? That means, first of all, we hold down the second function, that is v, then we differentiate the first function, then we use them to multiply, then we add it to what? We hold down the first function and then we differentiate the second function. Let me take that again. First of all, we differentiate the first function and we use the second function to multiply. That is what we have over here, v du dx. Then plus, we hold down the first function and then we differentiate the second function, then we multiply them, and then we add all together to get what? Our product rule. So with this basic introduction to how to use the product rule, let's go ahead and try some few examples to actually appreciate how to use the product rule. So example number 1, we have to find dy dx of the function y is equal to what? 3s squared plus 1, then 5x minus 8. This is our first example. So let's write down our solution. So we have the function what? Y is equal to, in one bracket, or that is the first function, we have 3x squared plus 1. Then the second function, we have what? 5x minus 8. So because we know these are two different what? Functions, and they are multiplying each other, we need to use what? The product rule. Alright, so by the product rule, if you're using the product rule, it means our dy dx, okay, is of the form, then we quote the product rule formula, that is what? V du dx plus u dv dx. Okay, once we quote it, we now have to what? Make sure what? We find each of these individual variables that we quoted in the product rule, and then we can be able to what? To solve the function. So let's say, to solve this, we say what? Let u be equal to what? The first function over here. So we have 3s squared plus 1, then v be what? The second function. So we have what? 5x minus 8. Now that we have this, we differentiate each of the function individually. So if we differentiate the first function, we are differentiating u with respect to x, so it becomes what? Du over dx. So our du dx becomes what? D dx of the function what? 3s squared plus 1. Okay, so we have du dx to be equal to, if we differentiate 3s squared, we get what? 2 now comes to multiply the 6, then we subtract 1 from the power, this power 2 here comes to multiply the 3, then we subtract 1 from the 2 over here, so it becomes what? 6x. Now this is a constant, so if we differentiate a constant, we get 0. Okay, so our du dx is what? 6x. Now let's differentiate the function what? V. So our dv dx becomes what? If we differentiate 5x, x has the power of 1, So 1 multiplied by 5 is still 5. Now if we subtract the 1, that is, we have 5. Now the power is 1, so we have 1 multiplying the 5, then we have x power 1 minus 1. So our dv dx becomes what? 5 raised x raised to the power 0, and then this is what? dv dx is equal to what? 5, because x power 0 is what? Is 1. So now that we have du over dx, then we have dv over dx, we now know what our u is, what our v is. We just go and then insert them into this formula, and then we get what? Our dy dx. So it means our dy dx for this example becomes what? V. Where is our v? This is our v. So we have what? 5x minus 8. Then our du dx is what? This is our du dx is 6x. So we have what? 6x over here. Then plus u. Where is our u? This is our u. So our u is what? 3s squared plus 1. Then we have what? dv dx. Our dv dx is what? Is 5 over here. Alright, so now we can proceed and then find our dy dx. So our dy dx becomes what? 6 multiplied by what? 5 becomes what? This multiplied by this becomes what? 30s squared. Then minus 6 multiplied by 8, we get what? 48 what? X. Then plus, we have 3 multiplied by what? 5, we get what? 15s squared. Then we have 5 multiplied by what? 1. Then we have what? Plus 5 over here. So it means our dy dx becomes what? This is s squared, this is s squared. So we have what? 45s squared minus 48x plus 5. Okay, so it means when we differentiate the function that we have over here, this is the result that we get when we use what? The product rule. So let's look at the second example. So the second example is what? Y is equal to, we have 2s squared minus 1. Then we have what? S squared plus 3. So looking at this straightforward, we know we are to use what? The product rule. So by the product rule, we say what? Let the first function be u, that is 2s squared minus 1. Then the second function be what? V, that is s squared plus 3. So we differentiate each of the individual functions. So our du dx, that is the differentiation of the first function, becomes what? If we differentiate 2s squared, we get what? 4x. We differentiate a constant, we get 0. So our du dx becomes 4x. If we differentiate v with respect to x, we get what? 2x. That is, the 2 multiplies the x, and then we subtract 1 from here, so it becomes 2x. This is a constant. We differentiate it, we get what? We get 0. So it becomes what? 2x. So from here we can now what? Quote our product rule. So from our product rule, dy dx is equal to what? V du dx plus u dv dx. So from here our dy dx is equal to, where is our v? This is our v. We have what? S squared plus 3. Then what? Our du dx is what? 4x over here. Then plus our u is what? 2s squared minus 1. Then our dv du is what? 2x over here. So from here we can just expand the bracket, and then we do our addition and subtractions, and then we get our final result. So we have 4 multiplied by what? S squared will give us what? 4x cubed. Then plus 4 multiplied by this will give us what? 12x. Then plus this and this will give us what? 4x cubed. Then minus what? 2x. So it means our dy dx is now equal to, we have s cubed over here, s cubed over here. So 4s cubed plus 4s cubed becomes what? 8s cubed. Then plus this is 12x, this is negative 2x, it becomes what? 10x. Okay, so if we differentiate this function and we use, that is, we use the product rule, this is our final result after differentiating the function above. So thank you so much for watching, and I'll see you in the next video. Bye bye.